Okie dokie. Still day 5. 25-minute timer is set. Let's rock and roll. I've written some tests, so more tests to parse different instructions. There was a bug. Well, possibly a bug. Again, it's down to how they've written the spec. I think it now is correct, and now we've got 3 for testing the ones which have memory-based side effects. So store, multiply, and add. So run instruction is going to run one single instruction and do its side effects. So the first thing it's going to need to do is let next be equal self.parse.next instruction. And actually, this might be a time to introduce iterates. There'll be a mutability problem there, maybe not. So, now, does run instruction need to return anything? Well, if what comes back is terminate, then it might need to, but we'll see. Now we've done all our error handling is just going to be fail to parse next instruction. So all our error handling is for nothing. Let's get rid of that to do. And then we want to match next, and where next is of type instruction add. And it's going to have so I could destructure these parameters. This parameter is a struct. And I can destructure this in place if I wanted to. So I'll do it just as params for add, and then I'll show what I mean on multiply. And it's just going to be self store mem. The address is going to be params.out. What do I call it? Params.store location. And the value is going to be params.input iter. Oh, there's a sum iter. ToString. Yeah, we need to store everything as a string. And what don't you like? And let's just expect that and go fail to store add. Parameters is a vec of I size, so it's far. Okay, and everything else for now is going to be to do. So, what don't you like about my to do? Do this. Oh, that's better. So if I cargo test now, run instruction add should pass. And it did. There it is, run add has passed. Cool. Right, next one, instruction multiply. And so parameters is a parameters struct. And I should be able to do inputs and store like this. I might need to look up how you do. I could use iterators again here. The pattern has 0 fields. Match destructure a struct. Match foo if it is of type that. Have I just got the wrong brackets? Written struct variant, use the tuple variant pattern instead. There we go, and multiply is not a thing. Pretty sure this is how I started it out. I'm still unhappy. Match foo. What if it is enum? So I could do that. What if I... And let's do the iterator again. So this didn't actually help that much here, but it's just something you can do. That's kind of the point. And it's going to be input iter. Probably going to have to not map. Fold. Fold takes an initial value, which is going to be a 0, and then it takes a closure over two values. Which way around are they? The accumulator and then the next value. And because this is a multiply, I actually want my initial value to be 1. And my closure is going to be ACC times X. And then we are going to do this to string. And so if I run cargo test, now the mem test should pass, and it does. Oh, sorry, multiply test should pass, and it does. Perfect. Next one up is store. Let's see how AI is done. Self.store mem. Store location and the actual value. Yep, that's fine. Great. Now, if it is load, and it's a memory location that it's going to get, I want to do exactly that, but I'm going to do it one line. Print line. Cool. And now what to do if I want to terminate? So somehow I need to pass a terminate signal back up. So we don't need this anymore because there is only one other match arm, and I don't want that to be there because when we come to add new commands, I don't want the compiler to fail. Sorry, I want the compiler to fail if I've not implemented the new commands in here. Whereas if I do this, then the compiler will compile quite happily, even though I haven't covered all of the instructions I've added, and it will just fail at runtime. And it won't fail at runtime until it reaches that instruction, which for advent of code might be a bazillion years in the future, who knows. So I want to make sure that I am actually explicitly covering all of my arms so that I get that compile time check that, yes, we're doing something sensible. For now, this is fine. This works, tests will pass. Now I don't have a test for load mem. I kind of could, ish. you capture print line? Maybe that's for a different time. If I wanted to terminate, I think what I'm going to do is, so what I could have done, that's returnable. Okay, so what this is now going to do is, if we need to terminate, return terminate. The other alternative is add a field to here and make it a side effect of running the instruction. And we already have loads of side effects because we're changing memory when we run. But yeah, it's not great. Now I need to go and change my tests because I need to assert. Is there a assert not out? Does that run? Yeah, that runs and it passes. I could actually just assert this directly. Like this. Assert not that. And then the side effect is going to happen. It's not particularly obvious, so I'll leave it there, but not for the rest. Store. Oh, I haven't got tests for load. Right. Let's test load. Load is num4. Yeah, we're going to run the instruction, and we don't need that. And then uh, 1099 assert, and then I actually want to assert this is true. Test run load and test run 7.8 failed. Because I let AI do stuff, and I missed it. I don't want to assert that, I just want to do it. So I'm just giving it a new instruction, 1.04, anything 04 is load. This is just this line up here. And again, the same down here. You AI fucked up and I didn't notice, and it's a good thing that that was in a test. Cool. Test passed. So now we just need to run the program, right? I mean, we also need to I'm going to say there are no outputs from this. It's just going to terminate when it does. While not self.run instruction. I need to put something in here. Or do I? Can I just have an empty body? Will that work? So what's the actual output I need? So this is all running. It's just going to be a test diagnostic. Start by requesting from the user the ID of the system to test by running an input instruction. Provide it one. The ID for the ship's air conditioning unit. Okay, so it looks like I might need, instead of just printing in my load mem, I might need to add an output store. After providing one to the only input instruction and passing all the tests, what diagnostic code does the program produce? I think I probably should have read this before doing a stream. Requesting from the user the ID of the system to test by running an input instruction. Provide it one. Is that part of the puzzle input? So I need to give it an opcode 3 with 1 as a value, which presumably I can fiddle my fiddle the memory. Okay. So then that puzzle input is going to go do some stuff. For each test, it will run an output instruction indicating how far it was. 0 means test was successful. Non-zero outputs mean the function is not working correctly. Check the instructions that were run before the output instruction to see which one failed. Oh god, am I going to need logging? Okay. So I think basically I need in my Intcode, I need an output store, which is going to be a vec of I size. And hopefully it's going to be filled with a bunch of zeros. And that's fine. So actually now I can do a proper test on my store. So it's going to load. Sorry, load is the one I need to proper test on. Cool. And then assert that some memory value is something. So what is it going to be? Load is going to pick up whatever is in the fourth position. So 0, 1, 2, 3, 4. So it should be 33. And I want it to be 33 as a number. Output store. 33. Right, this test fail. Great, as expected. All I need to do is go back to run instruction and find load. And instead of doing a print, I'm going to self output store push. And is that all the right brackets? Looks like it. Nope. Dot expect dot parse size and expect failed to parse load. Why? No. Close. push bracket. Yeah. What don't you like? Expect the ISI found string, that's why we're parsing it. Yep, that works, and then there's an expect on there. There we go. Failed to parse, memory has ISIs. Cool, that passes. I think this is ready to go, and all it's going to be is pubfun run is going to return ISIs. I need to construct my intcom. And really I should so I could do this as I don't care about it failing anymore. I could do this as the actual thing that will implement this. So we're going to split on commas, which is a vec of string, which is exactly what I want as memory. Going to get collect and memory instruction pointer. That should be fine. Incom is going to own it, so incom gets to decide if it's mutable or not. Turn part 1, part 2. Fun part 1 turns an ISIs, which for now is going to be 1. And part 2 is going to return ISIs, let's make it 0. I could go and test that new function if I really wanted to. Not taking a reference to a string, it's just taking a string. And we should get this. Which way am I putting these? Expect on right. Probably not correct, but and it's from string. Did we not? Oh, it didn't do this. Boom. Right, part 1 then is going to load some data. So Or am I going to do this? No. Ooh, that's a 25-minute timer. Cool. This is not what this is going to do. This is just income. Right, I'm going to need to make stuff public, but we'll get to that in a second. So I shouldn't have deleted those. I should have just copied and pasted it. Okay, and main.rs, do those for day 5, day 5, day 5, day 5. Okay. Right, so part 1, let me just remind myself of how I've been. Yes, these. Let's go grab that. Let path be equal to path new. What was the use? Standard path. Right, so then we've got a program string of type string, and I'm going to do intcomp. It's capital I, isn't it? Intcomp capital C as well. Should really know what I called this, capital C. Intcomp from string. We're not going to take a reference. Just going to own it. Own it, baby. Let mute intcomp be that. Now, the very first instruction, presumably, is a read. Shouldn't really be seeing puzzle input. I don't think anyone's going to be able to replicate this. Come on. Where's home on this keyboard? There it is. So the very first instruction is a read at whatever is in position 225. And that needs to be a 1. I think is what it's saying. That's how input works, isn't it? Takes it and saves it to the position given by its only parameter. Instruction, example instruction 350, takes an input value and stores it at address 50. Oh no, input doesn't work the way I thought it does. Oh, input is an actual input method. All of this is wrong. Well, not all of this is wrong. The story bits are wrong. Store is still useful. It's just that the instruction input itself, that's why I've called it store, because I'm an idiot. Right, well, for next time is reading the instructions and fixing my mistakes.